Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 226, and today is our lesson number 98. Today is our lesson number 98 on page number 226. We are dealing with the concept of quadratic equation. Quadratic equation, let's take a look at it. The equation that is given to us is x squared minus x minus 6 equals 0. Now listen carefully, please. There are two ways you can solve these equations. There are two methods that you can employ to figure out what values of x will satisfy this equation. And I say values because it has a second power, x squared. Because it has second power, it is called a quadratic equation. And because it has a second power, there are going to be two values of x that will satisfy this equation. Those values of x, those two values of x that satisfy this equation are called roots. There are two roots to it because it's a quadratic equation. Let me give you a simplest quadratic equation that you can find. How about this one? X squared equals 1. What values of x will satisfy this equation? What values of x? Yes, there are two of them. And the two values are positive 1 and a negative 1. This is how we write it. Positive 1 squared equals 1 and negative 1 squared also equals 1. Negative 1 times negative 1 is a positive 1. There are two values of x that will satisfy this equation. X squared equals 1. X can be positive 1 or negative 1. This is how we write it. Positive 1 or negative 1. For example, if someone says x squared equals, let's not use x squared, let's use a different symbol. For example, if someone says p squared equals 25, then p must equal positive 5 or a negative 5. There are two values of p that satisfy that equation. Similarly, this equation has two roots. Our job is to find those two roots. And there are two ways you can go about doing that. There are two methods that you can employ. One method is simply to memorize the quadratic formula and use the formula to figure out the values of x's that will satisfy the equation. That method, employing the quadratic formula, is right in front of you in the book. I'm hoping that you have the book in front of you. Turn to page number 226 and you will see show you there at the bottom of the page how to use quadratic formula to figure out the values of x's. The values of x rather. The problem is that I hate using the quadratic formula because I can never remember the bloody thing. I can never remember the damn thing. I always mess it up. I always screw it up. Let's use a different method. The different method that we're going to do today, that we're going to employ, the second method, is what is known as factorization. Okay, let's see how it goes. Factorization. I need the room, so I'm going to erase all of this thing here. We are looking for, so we're starting the process now, okay? We are looking for, let me erase this part too because I really need the room. In the factorization, the very first step is what I'm about to write. We are looking for two factors, two numbers, or rather two factors or two numbers such that That's why it's called factorization, because we're looking for factors, numbers, such that when we multiply them together, we get a product of negative 12. Now negative 12 comes from here, you see, watch here. This one has a coefficient of positive 2. Let me put them in the box so you can see it. Positive 2, this one x squared has a coefficient of positive 2, and this is a negative 6. If you multiply them together, a positive 2 and a negative 6 gives us a negative 12. That's where we get this part right here. This part comes from the coefficient of x squared, which is positive 2, and the constant, the negative 6. That's where the negative 12 comes from. That's the first condition we have to meet. The second condition we have to meet is that, and when we add them, we get the middle one. The middle guy, the middle coefficient is this guy. The negative, this is a negative 1 right here, negative 1 right here. We get a negative 1. Can you think of two such numbers? Can you think of two such numbers? Well, if it was only the first condition, if it was only one condition we had to satisfy, which is when we multiply them together we get a product of negative 12, the answer is right in front of us. It's positive 2 and a negative 6. You know, positive 2 times negative 6 is negative 12. It's very straightforward. But the problem is that when we add a positive 2 and a negative 6, we get a negative 4. We do not get negative 1. We need a negative 1. The coefficient of the middle one is what we need here when we add them. This gives us negative 4. This won't do the job. We have to think of a brand new numbers. So can you think of two numbers which when multiplied together will give us a negative 12, and when we add them we get the answer of negative 1. Well, that's very straightforward. We're looking for 12, you see? We're looking for 12. The fact that it is negative, we'll worry about that in a second. 12 is very straightforward. How about 3 times 4? 3 times 4 will do the job. Except here, we don't have a 12, we have a negative 12. So let's instead of put a negative in front of it. When we put a negative, then there are two possibilities. Either we have a negative 3 times a positive 4, or we have a positive 3 times a negative 4. Both of these scenarios will give us a product of negative 12. Negative 3 times a positive 4 equals a negative 12. And positive 3 times the negative 4 equals negative 12. The question is, which one of these two scenarios will add up to negative 1? Let's find out. Let's look at first scenario here. Let's look at this first scenario. Let's look at first scenario here. A negative 3 and a positive 4 adds up to positive 1. That won't do the job. We don't need a positive 1. They must add up to, here it is. And when we add them, we must get negative 1. Right here, negative 1 is the coefficient of the middle guy here of the x. This adds up to positive 1. This is no good. It must be the second scenario. It must be the second scenario, which is a positive 3 and a negative 4. Positive 3 and negative 4 adds up to negative 1. Voila! It does the job. It does the job. So now we found our factors. Now that we found our factors, the rest is downhill. The rest is downhill. I need a lot of room, so I'm going to have to erase all of this stuff. I'm going to give you 5 seconds if you want to pause this thing and so forth. You can always rewind it, obviously. That's the whole beauty of it. Why don't I utilize this 5 seconds to enjoy my sip of tea. So that's it. We have our factors. Our factors are negative 4 and positive 3. Let's start our work. So we're going to begin our work. I need the room. Let's erase it. So our factors are negative 4 and positive 3. Now technically what it is technically our factors are not simply positive 3 and negative 4, but our factors are positive 3x times negative 4x. Why positive 3x? Why positive 3x and negative 4x? Because when you multiply positive 3x and a negative 4x, we get negative 12x squared. Now I'm going to show you where that is coming from. Negative 12x squared comes from here. You see, this is actually 2x squared. This part is 2x squared, and the last part was negative 6. That's what we need here. So strictly speaking, I should not have put a box around negative 2. I should have put a box around the entire negative 2x squared. So we're going to do that now. Now we're going to show it properly. The box belongs to not just 2, but to 2x squared. Voila. There you go. So negative 2x squared times a positive 2x squared, and a negative 6 gives us negative 12x squared. Let's do that here. So we have 2x squared minus x minus 6 equals 0. We know our factors, which are these, which means we can write our negative x as negative 3x and a positive 4x. You see? Right here. This part here, the negative 3x and a positive 4x is our negative x right here. And then finally, we have negative 6 equals 0. Okay. Now we look at the first two. We look at the first two terms here. We look at the first two terms, and we ask ourselves, what do they have anything common? Do they have any factors common? Which is why it's called factorization. We're looking for common factors between these two terms. Well, I see x squared and I see x squared and x. We can take out x common. If we take out x common, what are we left from the 2x squared? From 2x squared, we are left with 2x, because 2x times x gives us 2x squared. Minus, if we take out the x common, if we take the x outside, we are left with negative 3. See? X times negative 3 will give us our negative 3x. Now let's look at this part. These two factors. Do you find anything common here? I see a 4 and I see a negative 6. We can take out 2 common. They can be both divided by a common factor of 2. If we take out 2 common, 4x divided by 2 is just 2x. You see, 2 times 2x gives us our 4x. Minus, since we took out 2, negative 6 divided by positive 2 gives us negative 3. You see, 2 times negative 3 is going to give us our negative 6 equals 0. Now we have to go one more step. Now we look at this part and we look at this part. Do you find anything common? Do you find anything common between the first part and the second part? And the answer is yes, of course. The common part is this thing. This part is the common part. This thing here is the same as here. We're going to take it out common. Okay, we're going to continue right here. I'm going to continue right here. So if we take out 2x minus 3, if we take it out, 2x minus 3, in the first part we are left with x. In the second part we are left with positive 2. And the whole thing we are told equals 0. That's it, we are almost there. So what happens if we are given two numbers, if we are told that a times b equals 0, what do you surmise from that? What do you gather from that? What do you infer from that? Well, if it's some number a times some other number b, when you multiply them together you get a big fat 0. There are only two possibilities. This implies that either A equals to 0 or B equals to 0 or both of them are equal to 0. There are three possibilities, not two. I misspoke. There are three possibilities, which means if this number, if this quantity times this quantity equals 0, then either the first quantity is equal to 0 or the second quantity is equal to 0 or both of these quantities are equal to 0. Let's find out. This implies that 2x minus 3 is equal to 0, or I should have put the word either. This implies that either 2x minus 3 is equal to 0 or x plus 2 is equal to 0. If 2x minus 3 is equal to 0, that implies in return that 2x must equal to positive 3, which in fact implies that x must be equal to 3 over 2, or x must equal to negative 2. Voila. Voila. Those are the roots. Those are the roots. The roots of this equation are, I'm going to erase this part beneath the room. So now we know that the roots of this equation, are 3 over 2 and negative 2. And we're going to verify that in a second. We're going to verify it. We're going to make sure that we did not make a boo-boo. I need the room again, so I have to get rid of this part. Okay? I have to get rid of this part. Let's verify. Our equation was 2x squared minus x negative minus 6 equals 0. Let's first put in a negative 2, which is the easier one to deal with. 2 times negative 2 squared minus a negative 2 equals 6. Let's see what it works out to be. Negative 2 squared is a positive 4. So it's 2 times positive 4. And a negative times negative is positive. So it's positive 2 and a negative 6. 2 times positive 4 is 8. 8 plus 2 is 10. 10 minus 6 does not equal 0. What the? 3 over 2 and a... You see, something has gone wrong. Something has gone drastically because this does not add up. It does not work. X does not equal negative 2 because it doesn't work. This does not equal 0. Now at this point I have to make a call. And the fact that you're watching it, you'll know what the call I'm making. The call I have to make is either retape the whole thing or carry on from here and redo the problem right in front of you to find out where the mistake happened. I'm going to redo the problem. Something has gone wrong. I have made a mistake. I have to go back and redo it. That's how you catch a mistake. You see how long did it take to do this part? It only took 5 seconds, 10 seconds. It is worth spending that extra 5 or 10 seconds to buy the insurance that you did in fact do the proper work in the exam. And when we did that, we realized it's wrong. It doesn't work. X does not equal negative 2. Something has gone wrong. And I have no way of knowing which part has gone wrong because of the fact that I am not doing it on a piece of paper where I can go back and retrace my step. You have it in front of you, obviously. You probably know where I made a boo-boo. I cannot retrace my step because I erased everything, which means the only way I can figure out is to redo it. So let's redo it. This is wrong. But this time I'm not going to explain everything. We're just going to do it. So our equation was 2x squared minus x. 2x squared minus x minus 6 equals to 0. So our factors are 2x squared and our factors were what? Negative 4x plus 3x minus 6 equals 0. That should do the job. because negative 4x and a positive 3x gives us negative x, and negative 4x and a positive 3x will give us negative 12x. So that's just the job. I'm not going to explain every single step, I'm just going to do it. At least you will get a chance to watch it again. So if you look at these two parts, these two here, I see a common factor of, I think previously I had a positive 3 here, didn't I? I could carry on like this here, it's just as fine, but I'm going to continue doing in a consistent way like I did last time so that you can compare the work, okay? And if you like, I'm going to solve it this way on the side here afterwards. Let's put positive 3 first. I believe that's what I had. Positive 3, positive 3x, and negative 4x. Okay, let's carry on. So take out the common factor from these two, take out the common factor of x. So we're left with 2x plus 3. Here, take out the common factor of 2, and we're left with x plus 2, plus 3 rather. If we take out 2, we are left with 2x inside. Four times 2x is 4x minus a 3. And that should be plus a 3 because negative 3 and a positive 3 is going to give us our negative 6. And that gives us 2x plus 3 and x minus 2. This is where our mistake is. X minus 2 equals 0. Equals 0. If x minus 2 equals 0, x has to be positive 2, not negative 2. So either 2x plus 3 is equal to 0 or x minus 2 is equal to 0. If x minus 2 is equal to 0, then x is equal to positive 2, not negative 2. This is wrong. This is wrong. This part was wrong. I don't know where it came from. This is wrong. I made a mistake previously. This part seems to be okay. Oh. This part is also wrong. 2x plus 3 equals 0, that 2x equals negative 3, x equals negative 3 halves. Our roots are negative 3 halves and a positive 2. Let's carry on. Let's verify it. Let's verify it. X equals to negative 3 or x equals to positive 2. Let's put it in here. Verify it. 2x squared minus x minus 6 equals to 0. Let's first verify this. Let's first verify this root, see if it works. X equals to positive 2 squared, positive 2, negative 6. 2 times 2 is 4, 4 times 2 is 8, and negative times positive 2 is negative 2, and negative 6. 8 minus 2 minus 6 does in fact equal to 0. That works. That checks out. Let's verify this root. 2x squared minus x minus 6 equals to 0. Negative 3 halves is what we're going to put here. 2 times negative 3 halves squared minus a negative 3 halves and a 6. If you open the parenthesis, this becomes 9. Negative 3 squared is positive 9, so we end up with 2 times 9 over 4 plus a 3 halves minus a 6. 2's are going to cancel out, and we end up with 9 halves and 3 halves. 9 halves and 3 halves and a negative 6. Let's continue here. We get a common root of 2. This has a root. This has a denominator of 2. This has a denominator of 2. So it's 9 plus 3 is 12. There you go. 12 divided by 9 plus 3 is 12, and 12 divided by 2 is 6, and minus 6 equals 0. Voila, it works. It does equal to 0. So it works. It satisfies it. Now what I'm going to do now, the very last thing before I wrap up the video, is to redo this problem in a manner that I had started out a second ago, where I put this negative 4x here and a positive 3x there. And you will see that we'll get the same answer. Let's do it. We'll get the same exact answer. Put a negative 4x here and a positive 3x here. So if you look at these two, the common factor is 2x squared, rather 2x, not just 2, but 2x. And from here we're left with only x, because 2x times x is 2x squared, and times 2. Because you see, 2x times negative 2 gives us negative 4x. And here, between these two, we have a common factor of 3. We have a negative 6 and a 3. Let's take out 3 common. We're left with x here, because 3 times x is 3x, and we're left with 2. You see, 3 times the negative 2, it gives us the 6. So from here, we have an x minus 2 common factor from here and here, and we're left with a 2x from here, and we're left with positive 3 here. Same thing, you see, which implies that x is equal to positive 2 or x is equal to negative 3 halves. Same thing as before. And you plug in both of those values of x in the equation, and you will see that it satisfies the equation. That's it. We are done. I will see you tomorrow, where we'll do one more problem like this with the method of factorization that you see on page number 227. The problem is that they give you the solution in the book there. They give you the factors, but it just drops from the sky. They do not tell you where they come from and how they arrived at it. So which is what we're going to learn tomorrow. Well, we're going to do the same method, which is what we're going to see tomorrow, as to how to find the factors. The problem number 2.4.2 on page number 227. We'll do it tomorrow, okay? Bye now.